Hey, you want to cheat at Scrabble? Let's write a Python program to do exactly that. So, Ravi, today we are going to do your favorite programming language, Python.
Yay!
I think I definitely have a surprise for you at the very end.
Okay.
Yeah.
Okay.
And I was just checking this. All right. I have a surprise for you. And what that surprise is, I'll let you know
Okay.
later.
Okay.
But anyways, today we wanted to do that anagram
Correct.
program.
Yes.
Right? All right.
Right.
Every single YouTube video or Google search that I have made always says or basically points me to programs on the internet where they find out if a word is an anagram. If two words are anagrams of each other,
Right.
which is not necessarily what I'm looking for.
Uh-huh.
What I was looking for is, I'll give you a word combination.
Yeah.
Find me the anagrams of or the anagram combinations of this.
So
this
just
word.
like I'll have 7 letters in my
Scrabble,
Scrabble,
in Scrabble,
and
yeah,
you can give me all the combinations.
all the combinations and maybe put them through an English dictionary filter and show you all of the
valid words.
the valid ones.
I can just
Right?
see it like that.
Yeah, no. You know, nowadays you don't even have to do that.
Right.
You just have to have a laptop in front of you and
Yeah.
say you're doing work, work from home,
Right,
and
right.
secretly
Yeah,
every time you
do
do that. Run this program.
Sure. Yeah. Let's go for that.
Yeah, let's go for that. So I just have like a simple. So I have a simple PowerPoint presentation put together. We all know what anagrams are, right? So if I give you AB, the anagrams of AB are AB and BA. The same goes for 3-letter words. It's AB. I mean, you get it, right?
Sure.
It's basically mix and match all of the letters in this word, and then you have the anagrams. The same goes for ABCD as well, right? There are 24 combinations. I mean, essentially what I wanted to show was that the number of anagrams of a given word is n factorial. Where n is the length of the word.
Right.
All right.
Right.
So if it is ABCDE having 120, I mean, it'll have 120 anagrams of each other. Now, we'll just discuss a little bit about the method we are going to use this.
Sure.
Like I said last week, we're going to be using recursion for this. All right. Recursion.
Something which is always piqued my interest. I'm not very good at it.
Right.
And it's very interesting.
Seriously, when you see it in action, it's amazing.
Right.
It's amazing. Yeah.
Right.
All right. So what's the easiest way to find an anagram of, let's say, a very simple 2-letter?
So you have to start with 2 letters.
We have to have 2
letters for
as
the
base
case.
as
Correct.
the base case. All right. It's actually pretty. It'll play an important role in the algorithm or the methodology, right? So we have A, B, and the easiest way to do it is assuming that str is an array. You just say str of 0 and str of 1. That will give you and str of 1 and str of 0, right? That will give you all of the anagrams of this 2-letter combination.
Correct.
Now, if we go one step further and let's say this is a 3-letter word, then it becomes a little bit. Complex, but there is an easy way out. What you do is you take 1 letter out of these 3-letter words, right? And then the rest of the words, you put it through the same anagram methodology. So in this case, you take, let's say, A aside, put BC through the same 2-letter combination over here.
Right.
So this is what I'm highlighting over here. For every combination that I require, I take 1 letter out, the rest of the words I'm putting it through the swap.
Correct.
Through the swap methodology, giving me all of the other giving me the rest of the anagrams.
Sure.
All right. Now this method also works if you have if the number of words go up, if the number of letters in a word go up. So in this case I have A, B, C, D. I take one of these things aside, one of the letters aside, put A, C, D through the anagram function. All right. I basically recursively call the anagram function taking 1 letter aside, which instead once again I take 1 letter out of this A, C, D. In this case I have taken A aside, put recursively call the anagram function for CD, which is once again CD, and you know what CD will return. It will return all of the combinations.
These two combinations. Right.
Now the 3-letter combinations, once again it will return all. I mean, basically it will go through every letter.
Right.
Take the others, run them through the filter.
Got it.
All right.
Right.
Now, if this image is not that clear for you, I'm really hoping that the pseudocode starts making sense. Right? So I have a function called Anagram,
which takes a word.
Yeah, which takes a word containing n number of letters on it.
Right.
So I have a variable which will basically hold the results of this anagram.
Right. So it's a list because there are many.
Yes, it's a list. It's an ever-growing list. So I have this. Now I just have this stopping condition over here, which basically says if that the word is, if the length of the word is 2, then I just basically do a swap, add it to the anagrams list, and then I return back the anagrams. Right. That's all it is. But if it is not, if it is more than 2 letters long, then I say for I in every letter of the word where I is an index, I take a letter and I keep it aside. This A letter variable over here is the one that I'm keeping aside.
Right.
So I have a word here. And then I form the rest of the word, which is basically the rest of the letters from the word except the letter over here. So if it is A, B, C, I take A out, take only B, C, and I have the rest of the word is basically B, C.
Right.
Which I recursively pass through the anagram function. So the anagram function is called back again with the rest of the word. Right?
Okay.
And which will return me the anagram of the
rest of the letters.
Rest of the letters.
Right.
So if it is BC that I'm passing to anagram, the anagram of rest will basically contain BC and CB.
Right.
Now, for every word that is returned in the anagram of rest, I take the first letter that I kept aside and I add it back to the word. What is word? Word is basically every element in the anagram of rest.
Okay, so what you're saying is if there is Ravi, then you will take R separately.
AVI, run it through the same anagram function.
So that will give you all combinations of AVI. Okay.
Exactly.
And then you add R to each of the combinations.
Which will return to me RAVI, RIVA,
right, all of those. Right.
So this very simple function uses recursion to find out, basically the recursion creates this stack of methods that needs to be returned. Okay. And then at the very end, the anagram will basically contain all of the words that.
Okay. Yeah.
So obviously, this methodology is a little bit slow. Not a little bit. It's actually quite. It gets slower the more number of letters that you add to it.
Okay.
All right?
Okay.
So I have found that generally when you, I have done this in JavaScript before, and generally anything more than let's say 8 letters tends to take a very long time. All right.
Okay.
So yeah, that's obviously because your method stack gets so large in the virtual machine or whatever environment you're executing it on. It becomes so large, and then it has to pop everything back out as the execution continues and everything. Right. All right. So let's put this in Python and see what comes out. All right. All right. So that being done. All right, so let's see. I know, Ravi, I'm going to be taking a lot of help from you for this one because I know you're kind of an expert on Python.
Okay. Not really, but yeah, I know some Python.
Okay. How do I import something in Python? Yeah, this is my Python program. This is my Python terminal.
Right.
Let's see. I'm going to open a new. Yeah, I'm going to open a new terminal.
Okay.
I'm just going to make sure that this is set to the correct profile.
Okay.
Right? For me to execute, it's big and everything.
Sure.
Alright, so nothing happens right now. So we are using Ubuntu over here, which is a flavor of Linux. And Python comes built into Linux. If you're using Windows or
Mac
OS,
you'll have to
even
download.
For Mac, I think it's built in.
Yes,
correct?
But that the versions are quite old, so you end up anyway downloading the later versions.
So for Windows and Mac, I think you need to download Python 3. I think the latest version is 3.8.
3.9 is also out.
3.9 is also out. Great. All right. Hey, how do I find out what Python version?
Python -v.
Yikes.
or minus version. Maybe minus version.
Yeah.
Not yet.
Not
Okay.
yet.
Minus E. No. Minus VER. No.
No.
Okay.
Yeah. Anyways, I know I'm using 3.4.
Okay.
I think I'm using 3.4.
3.8. Why is it coming? Okay.
Where?
Python 38.
38. Oh, all right. I mean,
Okay.
I don't think this is important.
Yeah. Sure.
Python
It doesn't
3
make
is what
any.
I'm using. Yeah, it doesn't
Correct.
make any difference
Right.
as to what we are doing over here. All right. So first things first, I need to import the arguments. Let me just look up the documentation. Yeah. So I will need to import sys.
Correct.
And this is so that I can take arguments from the system. All right. So I want to pass arguments to my program.
Yes.
And I would say if sys dot, is it arguments?
argv.
Sys dot argv. Oh, okay. So I can say if len
Okay.
sys dot
Yeah.
argv is equal to, is it 2 or is it 1?
The first one is the program
It's the
name.
program name itself, so
Yeah.
it should be less than 2, right?
Then
I mean,
you
if
want
it
to
is-
say an error.
Yeah.
Okay.
I just want to say
Sure.
all right. So now I have so now I have this. New lines of semicolons. What does that mean? Oh, right.
Yeah. That's what happens when
Yes.
you shift to the
Yeah.
other languages. Yeah.
So yeah, how do I do this?
Exit.
Oh, okay.
Sys.exit. With say 1 or something, right?
Yeah, 1 because
generally
that's
that's
an error
the
condition.
yeah generally.
Let's see how that works.
Yeah.
Yep, I think we're good. All right.
Yeah, very nice.
Yeah, that's it. I mean, we have this one. Let's write a function
Uh-huh.
that will actually do that for us, right? I mean, which will find the anagrams.
Ah.
So going back to the pseudo-code,
Right.
so find anagrams,
Okay.
which will take a word, right?
Correct. Right.
Do I have to specify the parameter type?
No,
Right? Yeah,
no.
so I have a word. So just like JavaScript, I don't have to specify
Correct.
anything.
Correct.
So I'll say anagrams is equal to nothing. I mean,
Uh-huh.
basically it's a list.
Right.
Say if len of a word is equal to 2. If it is exactly equal to 2, then anagrams dot push.
Okay.
Correct?
Uh-huh.
Yeah.
Or append.
Oh yeah. I'm sorry. It's append. It's push in JavaScript. yeah. Dot append. Yeah. Push is the same as append in
JavaScript.
JavaScript.
Yeah.
And the same thing
With 1 and
with
0.
1
Very
and
nice.
0. That's about it, right? It's pretty easy.
Yeah.
So I have the anagrams, and I can say return anagrams. Correct?
Uh-huh.
Yes. That's
Sure.
it.
Yeah.
Now here I'll just say return. How do I return null? Is it null
Yeah.
or
Small.
nothing? I mean, I know.
Nil. NIL. None. NONE.
Yeah, it is none.
Uh-huh.
All right. I'm just returning none
For the
because,
time
Yeah,
being.
for the time being. It's just as a placeholder.
Right.
Let's just see if this works. Oh yeah, I'm going to say test. Nothing should happen.
Right.
Oh right, I'm also not
You want
printing anything. I'm not not even invoking this.
Yeah.
anyways.
Sure. Right. Yeah.
So I'm going to say word anagrams is equal to find anagrams of. Oh, I'm not even capturing the input. So I can say
sys.argv1. You can just.
a word is equal to sys.argv of 1. Oh nope. Let's see. And I'll say print word anagrams. See what happens.
Sure.
Nothing because I'm not doing anything. But let's say if I
Because
say
we don't.
yeah.
Yeah.
So it should return
Perfect.
the anagrams. All right.
Right.
All right. So now I have this. I'm going to remove the return none. I'll say. Since I'm returning
anagrams, you can return anagrams here also.
Yeah,
right,
here
right,
also.
right,
Yes.
right.
So now let's see. Now I have to say for how do I say index I? Basically I need to go through every word of that.
You can just
directly. I can just say where I in range, right? Range of len word. Maybe there's a better way.
If you want to use index, this is the way.
This is the way. Correct. Yeah. So yeah, basically we need to separate out one letter and then take the rest of the letter.
Yeah. The shorter way is also you can just say for I in word, which will directly give you that character. But I don't know if you want to do that. That depends on how you want to.
Yes, I don't want to do that.
Right.
You know why?
Right.
Okay, let me just type it out here. Let's say I want to find the anagrams of
Ravi.
Mood. No. I specifically have chosen a letter which has 2 in it.
Correct.
If I let's say use indexes. Right. Now, if I have to have the rest of the letters, I need to make sure that I don't include the same letter in the rest of the letters. Right? So if I was choosing O as the letter that I keep aside and MOD as the letter that I'm going to be recursing, then I want to make sure that this O is not in, that this O is not considered again, right?
But how will you do it with indices then?
With indexes, I can just say I and J, right? I can use I and J, and I can say if I is equal to J, then continue. Don't consider this word. If I was using the letter, then it would get confused and it would remove this also from the anagram that I need to find.
Okay.
So we don't want to do that.
I think we should, this double letter case, we should keep it in mind later, or should we do it? Should we think about that now itself? I don't see any issue with that. So if you do take the second index, that is, let's take mood itself. So if you go through the list without, or you could do this case that when you can check when you're adding to anagrams, that anagrams doesn't have that. So what I'm saying is, suppose there is mood and you're taken O aside, the second M aside, M is okay. M is done. Work. The first O will take MOD the rest of the letters. The second O will also take MOD as the rest of the letters.
Yes.
So might cause, if we don't check, it'll cause duplicates.
Exactly.
Or you could make it a set.
You could, I could make this a set.
The list instead of list, you can just use a set. And just use.
But then we need all of the anagrams. We need all the anagrams, right?
But do you want duplicates?
Let's say one of the anagrams of mood is doom.
Correct.
If it was checking for O in the rest of the letters, then it would only have one single O. It would return only DOM.
No. The only case where there are problems is when you the letter that you take aside is O.
Yes.
Because that is the one which is being repeated.
That's the one that is being repeated. Correct.
So when you take aside O, then you have DOM left.
Correct.
And even if you do that again for the next O, which is what will happen if you do indices. If you do just go through all the indices.
No, but then for indices, I can say if the parent index is the same as the child index, ignore it. Don't take it in. Don't take it in the rest of the letters.
Okay, I'm not sure. So as long as we are clear that this is a case that
when I type this program out, when I go further, I think
you'll get handled it. Okay.
So I'll say a letter, which is basically I'll take this one, a word, and I'm guessing it's just I like this, right? Yeah. And then I have the rest of letters, which is just this one, and I can say for J in range of len of a word. Basically, it's an inner loop also going through a word. Okay. And I can say if I is not equal to J, only then rest of letters plus a word of j.
Right.
Right?
Right.
So at the end of this, rest of letter should contain the rest of the letters.
Right.
Let's just print this and see what happens. Right?
Yeah.
So the function starts here and the function ends here.
Uh,
Right? I mean, it returns an empty list of anagrams.
Okay.
I'm just printing the rest of the letters. Let's see
Right.
what happens. So the rest of the letters is EST, TST,
Yeah.
TET. Yeah.
Yeah.
Oh, I should put it outside of
Yeah.
this.
Yeah.
Yeah.
Correct.
There you go. So that's the rest
Super.
of the letters, right?
Right,
So the
right.
T was taken out first,
Correct.
and E was taken,
Correct.
S was taken,
Right.
and then TES.
Right.
Right?
Right.
Now we can find the anagrams of the rest of the letters, right? Yeah. I'm just going to call it anagram rest is equal to find anagrams of rest of the letters, right?
Right.
Now I can say for a word or word in anagram rest. You want to call it rest word or something? Yeah, I'm just going to call it rest word so that it's a little bit easier to understand. All right. So now I have the anagram of the rest of the letters.
Right.
Take the anagram. Take each word.
Correct.
Append the A letter to
Perfect.
this. Right. So I
Right.
just say anagram dot add or append.
Yeah.
Dot append a letter plus anagram rest.
No. Rest word.
Oh, I'm sorry. This rest word.
Yeah.
All right. It says there are a couple of. Oh wait. How does this work? Is this correct?
Yeah.
I mean,
You don't need the.
I don't need the braces
Yeah,
and
yeah, yeah.
everything. All right. So essentially, anagrams over here
Yeah.
should contain the rest of the letters.
Okay.
All right. Oh my
Wow.
God. There it is. Yeah.
Okay.
I'm going to remove the print here.
Yeah.
Let me clear my screen. Okay. All right. Yeah. So
That's
that's
like already done.
it's already done. I
Right.
mean, yeah. At this point, we are essentially done.
Right.
But let's.
Yeah.
But this doesn't help you in Scrabble.
Right.
Because what? All right. Let me just show you this.
Uh-huh.
Remember how I was telling you that because we are using recursion, that method stack within the Python game
Correct.
is growing exponentially larger, and then
Right.
it has to execute everyone and then
Yeah.
push out the stack and pop and everything.
Correct.
Let's see what happens if I give 8 letters. I'm going to say Ravi Sri, which is 8 letters.
Whoa.
I wasn't expecting that.
That was fast, huh?
The reason for that
Uh-huh.
is because I have only used JavaScript. And JavaScript, it's very bad.
Oh, okay.
It's very bad.
Right.
I wasn't expecting that.
Okay.
Hey, hold on. Let's
Yeah.
find out how many words it printed out.
Sure.
And I'm going to hide this for just a moment because
Yeah.
There were len of word anagrams. Oh, I don't need that space at all. I'm just going to say comma.
Yeah. Comma is easier.
Yeah,
now.
comma is easier. It's and I don't need that space and plus and all of those things. I think it's a little bit easier over there.
Yeah.
What is 8 factorial?
Whoa. I don't know.
Yeah, that's correct actually.
Wow.
All right, yeah. I mean, so if I 120.
Perfect.
Yeah. So there you go, 720, which is correct.
Correct.
Yeah.
Correct.
Yeah,
Wow.
that's correct. All right.
Perfect.
But let's do 9 characters.
Right.
Even
Slide.
that was fast.
That was fast.
Even that was fast. Even this is.
Yeah.
I was not expecting that. Honestly.
Right.
Should I say 10?
Sure.
The reason why 7 is good is because that's how many numbers, how
In
many
Scrabble.
letters in Scrabble you have.
Yeah.
All right?
Yeah.
Yeah.
Oh, now it
Yeah,
starts
now it's
struggling.
like,
So it's so interesting that adding one letter just increases the
increases. You can see the
because
difference.
it's
There was
exponential.
Yeah, for 8 letters there was 40,320.
Okay.
Oh wow, look at this. For 9 letters it found this much.
Right.
Wait a minute.
Wow.
Is that 9 or 10?
No,
my
it
God,
is.
this
It is
10.
one digit extra.
Yeah, it is one digit extra. It is
Yeah,
10. So
yeah,
I think
yeah.
that is 3.6 million. No. It's 300. Yeah, it is 3.6 million letters.
Right.
Combinations,
Wow.
basically. So you can imagine how deep the method stack would have been in
Absolutely.
the VM. All right. So
Amazing.
yeah. So this, however,
Yeah.
let me just put this, and I'll put the word anagrams back,
Mhm.
and let's just stick to
Yeah.
what we understand. But you can
Right.
see a problem over here.
Uh-huh.
This will not work in Scrabble
Right.
because it's returning only those letters that are exactly 4 letters wrong. Right? I mean, we want all of the words that were there in Ravi also. So it should be R-A-A-R-V-I, I-V, I-R,
Oh.
all of those
Right,
also
right.
it should essentially
I
return,
see what you're
is
saying.
what I'm trying to say.
Okay.
But the amazing thing is we are already calculating the anagram
Correct,
for
we
of
are.
the individual things
Yes,
over
yes.
here also.
Correct.
So I can actually declare a variable here, and I can say I'm going to call it all length anagrams is equal to this.
Uh-huh.
All right. I mean, basically this will serve as a global variable for me.
Right.
I'll take this global variable and I'll just simply this rest of the anagrams that I'm putting. Hey, how do I add arrays? Is it just
Yeah. Lists. You can add lists.
right?
Yeah, you can.
What is this? Why is it saying?
You can just say plus equal to if you want. But that also was the same thing that you were saying. No?
Oh, you know what? I
Length
think
anagrams.
is it because I've declared it here instead of
Yeah.
on the top?
Maybe.
Right. So I'm going to declare this on top.
Still giving that same error.
Is unbound.
It's not finding that.
Okay. Oh, you know what? I forget that. I'll just add it here, man.
Okay.
Sorry about that.
No problem.
Forgot to put this on mute.
Uh,
All right. So I can just say all length anagrams dot append
rest word.
I don't have to do anything else.
Correct.
All right.
Correct. Yeah.
Now let's see. All length anagrams. All right.
Right.
So so now we have 2 arrays. Yeah, there you go. So that's VI, IV, AI. So
Everything.
all of them.
Sure.
And now this is a perfect Scrabble. I mean, this is
Right.
exactly what you're looking for in Scrabble.
Right.
You want to make sure that you get all of the
combinations
that are available.
But I also want to exclude all the useless combinations.
Exactly, right?
Right.
IAV, for example, is
Yeah.
definitely not a word, but
Right.
VIA is via.
Correct.
No, is it?
It
Yeah,
is,
it is
yes.
VIA.
Yeah.
Yeah, that's actually a word.
Yeah.
All right, man. So for that, I have like this huge text file
Wow.
containing a list of all of the English letters.
Okay.
Right?
Wow.
Let's
Okay.
filter it through that.
Okay.
All right.
Yeah.
So for that, we will first need to open the file.
Yeah.
How do you open a file in Anagram? I know.
So there are two ways.
so
One is you can use the new Pythonic way,
Okay.
which is goes like with.
Oh.
So with open and your file name. Open takes the file name. No, it's a function, so it's a method. Yeah.
Like this?
Yeah.
Okay.
Okay.
Oh, okay. All words.txt. Okay.
And then as a handle for whatever
Oh,
variable.
okay. A file handle.
Yeah.
Okay. I'm just going to say FIL.
Yeah,
For
yeah.
file input.
And
Right.
this is again a scope. So colon. Yeah. And then you start
Okay.
doing
now
whatever
I can
you
just
want.
basically.
read lines is read.
Yeah, I can just
You
read.
want to do read?
Right? Yeah. So what I'll do is I'll just I'll declare a variable here, right?
Yeah.
I'll say all English words is equal to this.
Right.
So as you can see in this file, they're all comma separated.
Correct.
So I want to like
Split them
split them out. So I'll first have to read them, right?
Right,
So
right.
fin dot read. That's it. I mean,
You
what
can
is that?
actually chain functions.
Oh, okay.
Yeah. So you can actually do the this is fine, and you can do the dot split on it.
Really?
Yeah, and
oh my god. Okay.
yeah, and then read the perfect. Yeah, I think this should be
all right. Yeah, let's print it out, see what happens.
Yeah.
I'm going to hide the anagrams for now. I'm going to hide all of the other input for now.
So the go ahead.
It actually worked.
So the
I
advantage.
believe that worked, man. That's so
Python.
easy.
Yeah.
Oh my god.
It's called function chaining. So the good thing about with is now
Yeah.
you notice that we didn't do actual closing.
Oh yeah.
So that with takes care of the closing.
Huh. Okay. Oh,
Yeah.
it takes care of the closing.
Yeah.
Oh, okay.
Yeah. So
That's-
you don't have to worry.
Oh my god.
Cool, right?
Yeah.
That's what the power of Python.
Yeah.
I mean, we hardly scratch, but even then we know
Yeah.
how. More than powerful, I think it's just so easy to write, like you just said.
Yeah.
You just do it and it's done. Yeah.
My goodness. All right. Yeah. Getting back on track. Hey, you
Correct.
know what?
Yeah.
I mean, basically, we'll have to filter out all of the words in the all length anagrams with whatever is present.
Yeah,
I mean,
yeah,
with the
yeah,
English
yeah,
dictionary.
yeah. Correct,
all right?
correct.
But before we do that, let's remove all duplicates.
Because
Because 100% are
correct.
I mean, even if I was to, this will have duplicates.
Correct.
Let's filter out duplicates. I believe it's, I can say set.
Correct.
Yeah, basically convert it into a set and
Yes.
then convert it. Do I have to convert it back into this? No, let it be a set.
Right.
I can convert it into a set like this. Right? And a set will only have unique elements.
Correct.
So I now have the unique elements.
Perfect.
Now I can say for English word in all English words, and I'll declare.
Why don't we do it the other? Won't this be a smaller one? I mean, so won't our anagrams be a shorter one?
Anagrams. I mean, I want to take every English word, which is basically a list,
right,
and search it in the anagrams, which is a set.
Okay.
Searching through a set is faster than searching through a list. That is my thinking, or that's my thinking.
Okay.
Because I believe it's a binary tree in Python.
Sure. I was
compare.
thinking the other way around. But
I mean, I know what you're thinking.
Yeah.
You're thinking
forward
loop through the set, and then search for it in the English.
That's
word.
what I would have thought.
Right?
Yeah.
But I'm saying let's do the other way around because I believe searching through the set will be faster.
Okay. Interesting.
And now you're only thinking of 4-letter combinations.
Correct.
Once it gets to 7, you'll have
yes.
so many letters.
Correct.
Let's try this and see what happens.
Sure.
Or I mean, if the performance is bad, we'll go the other way.
Sure.
So let's say if this English word appears in the set, how do I do that?
Correct. That's it.
In all length anagrams.
Yeah. Correct.
In all length anagram. And I can say English anagram dot append English word.
Perfect.
All right.
Yeah.
And I'll say print. Here is all. I'll say print English anagrams. So there you go. Right.
Yeah.
Oh man, is it really so simple? Oh, yes, it is.
Oh yeah,
Yes,
that
it
was
is.
good one, and that was fast. Also.
That was really fast.
Yeah, that was very good. Very, very cool.
Yeah, let's see.
Some random 7-letter word.
Yeah, 7-letter word. And in Scrabble, you'll get like, let's say you get the worst of the worst. You get 3 E's, 1 P, Q, T. How much is that? 6. And I'll put an N there.
Okay.
Oh my god. Okay, so here are all the English anagrams.
Wow.
There's no way. Okay, there's no way any. Okay, anyways, ignoring that because my dictionary essentially contains that.
That's what. There are so many of these words in Scrabble which people use. The professionals,
they'll
use such words.
They'll use such words.
And they'll say it's there in the dictionary.
Alright, anyway, so there's net, pen, pent. Look at this, TP.
Yeah,
that's
TP.
the longest word that was
Perfect.
there.
Very nice. Very
Hey,
cool.
let me just hide this,
that print.
That print.
Yeah.
Just a moment. Let's just go back.
Very cool.
Let's take another 7.
Yeah.
G. You're very unlucky. You get 1, 2, 3, 4, 5, 6, like this. What is that? 8?
Now 8, yeah.
7. Oh my god.
Perfect.
Yeah.
Yeah, this is what we need.
This
for
is what
Scrabble.
you need. Yeah. So what you do is
Yeah.
that, you know, let's say your wife or your dad,
Family.
somebody is sitting over there. You say you're doing work from home.
Yeah.
Have the laptop open.
Have the program. And then score all the 7-letter
So
words.
7
Oh man. Yeah.
Hopefully they don't walk across and see you.
And what do they know? They'll just see code. If they see a website, then they'll get suspicious.
Yeah. So yeah.
Very nice. Yeah. Very cool.
I'm gonna try my name.
Yeah. Mm.
You know what?
Yeah,
I'm just
yeah.
gonna put everything. That's
Yeah.
10 letters.
Yeah.
Oh, that's a lot, man. That's a lot.
Okay.
Let's say 9.
That's still fast enough.
man.
Yeah.
So the longest word I guess you can put is radish,
Yeah.
darkish,
And you can even sort that
by the
output.
length.
Length.
Yeah. You can like sort it by
sorted. It's very
and then
simple.
you can
actually.
say this is the
longest.
and nice. Let's say Ravi, RAVI4 SREE. 8 letters. Easier.
Wow. Easy.
Reverse. Razor.
Right.
That's okay. All right, man.
Mm.
I told you I had a surprise for you at the end.
Yes.
Right? Now the thing is,
Mm.
I had some time to actually work on this,
Right.
and I wrote this in C also. I wrote this in C also, just because I wanted to know what the performance looks like in C versus in Python.
Correct.
I'll just show you an image which I think is like extremely appropriate as to what I felt was the difference between C and Python. Right? This is literally what it was. In C, you had to make everything. Set and
The
list and everything I had to write. Man. There was, even the string wasn't there.
It wasn't easy.
It wasn't easy. And it's been such a long time that I've written in C. I've almost forgotten.
Correct. But I would still think C is much faster.
Much faster. Right? All right, man. All right. That's what you think. Let's see. I'm going to open a window in C. Now I have some performance statistics and all of those things written in the program.
Okay.
Say code space. All right.
Okay.
Reduce the window size because I'll have the Python window also open below.
Oh, okay. Got it.
Yeah. I'm just going to rearrange this. Take a moment to rearrange this so that I have the Python window also open. Okay. That being said, let me go to the alright, so I have the Anagram program already compiled and everything. Anagram and 8 letters.
Okay.
So I have, like I was saying, I have some performance statistics done over here.
Yeah.
So it took 68 milliseconds to find all the anagrams. It puts the count and everything. It took 1 second to remove all of the duplicates, right? And then it took 156 milliseconds to filter the words.
Got it.
Right? But let's compare it with Python.
Okay.
I have the same program written and it's called Anagram Perf.
Right.
So I'm going to say Python 3.
Okay.
And check it out, man.
Oh gosh.
Now it's a little bit slower as far as find the anagrams.
Correct.
Whereas the C program took only 68 milliseconds.
Yes.
This one took 87 milliseconds.
Right.
But look at where it absolutely crushes Python.
Right.
25 milliseconds to remove duplicates versus a second. 10 seconds to filter words versus 150 seconds on it. That being said, I said, I had to build the list, the binary tree, and everything in C. So this is, you're comparing something that was absolutely optimized to something that was to something that was written by me, which is, and it's been I think 15-20 years since I've written a program in C.
Correct.
But even then, I would have expected that because there is no interpreter layer in between the code and the between the code and the machine, I would have expected it to crush it. But I was very
Wow.
unpleasantly surprised. Yeah. And
Wow.
I can totally see why people prefer Python for big data and data mining and all of those operations. Right?
Right. So list operations and so on, definitely
It's
it's
just
optimized.
Crushed it, man. It's just
Wow.
crushing.
Wow.
Yeah. So I know
Wow.
this was a very I mean I
That's
think we are at
amazing.
the end of I think we are at the end of where we need to be with this anagram thing. But what is the use of doing this anagram thing, right?
Yeah.
Let's look
apart
at,
from Scrabble.
Yeah, apart from Scrabble.
Cheating
apart
at
from
Scrabble.
Let's look at this thing called as the traveling salesman problem. Right? I mean, you have
very famous computer science problem.
Yeah, computer science problem.
Right.
Given a list of cities and the distances between each pair of cities, what is the shortest possible route that visits each city exactly once and returns to the original city? I think we've had this discussion before. And you were telling me about the greedy algorithm.
Correct.
That's one way of doing it.
Right.
The other way of doing it would be to brute force all of the all of the locations and all of the combinations that are available, finding out the distances between them. And I think that's called as the exact algorithm.
Oh,
right? That's the exact algorithm
where
you evaluate all of the distances and all of the locations, and then you find the distances. Right? So if you were to so let's say you did have something like this. You just mark every location as a letter in the alphabet. So this would be A, B, C, D, E, F.
Yes.
And then you find the anagrams of all of them.
Right.
Find out the anagram and find out the
total
distance. The total distance
yes.
of that specific location, of that path.
Correct.
And if you do that, it's an exact algorithm where you have the where at the end you just take the minimum of all of them, and that would be the shortest
path. Will be the
that 100% would be the absolute best way to do it, but it would also be the slowest way to do it.
Especially if the n number of cities
increases. Anything about 10, I would say it is not possible.
It's not feasible.
I mean, you'll have to one way to give some respite to your CPU would be to thread it, would be to have it run its on its own thread, run it for a few days and see what comes out. That would be one way of doing it.
Right.
By the way, the traveling salesman problem, it's not just a computer problem. It's also used in things like astronomy. Right? I mean, like telescope time is actually so expensive. Right? I mean, you can't just willy-nilly. Let's say let's say you are a scientist and you just use the telescope to point at something in that direction. Because I can come in later and see and look at something in this direction. You want to minimize the movement of the telescope.
Wow.
So what you do is you line up all of the scientists who want to use it and say which is the best order of scientists of telescope movement.
That's interesting. Very interesting.
So that's one of the uses of traveling salesman problem.
So for audience who doesn't know, RK is very into astronomy. Right? Space and all that.
Space. Right? Maybe we should do an episode just on that.
Right.
We should do it just on that.
Okay. Yeah, that will be interesting.
Hey, oh my God! Speaking of astronomy, I think ISRO's launch just went.
Ooh.
Yeah, they were launching. I think it was a spy satellite.
Okay.
And I have this guy called Garib Scientist, who is an absolute best.
Oh, okay.
Who's the absolute best?
Oh, very
cool. As far as covering all of these is concerned. I really like this guy.
Right.
Right now he's covering the he's covering the launch live.
Yes.
Yeah. So it starts in 18 minutes. The launch is in 18 minutes.
So for audience who are interested in that,
it's in 18 minutes.
Okay.
And I think it's a spy satellite.
Okay.
There are other riders also on the craft.
Very cool. Yeah. So very nice. That's a good use of the TSP. Yeah, very nice.
The traveling salesman problem. Yeah.
Very cool.
All right.
Very.
That's it, man.
That was a nice one.
Next week,
yes,
you want to do something. Let's get back to some coloring, and I've wanted to do this domain coloring thing.
Oh yeah, you were telling me.
You convert, I think, functions into colors. It's a nice way of visualizing colors, I think.
Wow.
So join us again next week. Let's do some domain coloring and see how that turns up. That's all I had. Thank you. Hey, like, share, and subscribe. Seriously. Thank you so much.